Hi folks, we're going to take a look at a question about implicit differentiation. This is page 178 2M. So I'm given this function or relation that's defined implicitly, and I want to find the derivative of y with respect to x. Okay, so our first step is to take the derivative of both sides. Okay, so we'll do that. Okay, now we see the right-hand side is nice and easy. It's just a constant, so that'll be 0. But now here, I'm going to use the subtraction rule to break this up into two derivatives, the difference of those two derivatives. So let me start with this one here. So I see that I've got the product of x and y cubed, so I'm going to have to use the product rule. Okay, so first thing I'm going to do is use the product rule on this one here. So derivative of the first function, which is just 1, times the second function, y cubed, plus the first function, x, times the derivative of the second, which is y cubed. So this is where now I have to use the chain rule. So first I take the derivative of y cubed with respect to y, so that gives me 3y squared, and then I take the derivative of y with respect to x. Now here I'll use y prime, okay, just to make it easier to write out. Okay, now minus, so let me open up a bracket here just to make sure I don't make any silly sign errors. I need to now take the derivative of this part, which is also a product of two functions. So again, I'm going to use the product rule. So derivative of the first is 3x squared, okay, times the second function, which is y, and then plus the first function, x cubed, times the derivative of the second function, but that's just dy dx, which I will write as y prime. Okay, and then equals derivative of 2 is 0. Okay, so step 1 is to take the derivative of both sides of the equation and apply whatever derivative rules I need to do that. In this case here, I needed the product rule twice, and I needed the chain rule for y cubed. Okay, so now what I'm going to do is I'm going to group together everything that's got a y prime on one side of the equation and bring everything to the other side of the equation. So here we've got 3x y squared y prime, and then here I've got minus x cubed y prime. Okay, I'll leave that on the left side of the equation, and to the right side of the equation I'm going to bring these other two terms that don't have y prime. So here I've got a minus 3x squared y, so I'll bring that to the other side. It becomes positive 3x squared y, and then here minus y cubed. Okay, and so now we factor out the y prime on the left side, and we're left with 3x y squared minus x cubed equals 3x squared y minus y cubed, and now we can isolate the y prime, which is what we're looking for. Okay, so here we've got 3x squared y minus y cubed over 3xy squared minus x cubed. Okay, and there we have it, derivative of y with respect to x, given by this expression, which of course contains both x and y values. So you might want to take a quick look to see if you can, if there's anything that you can simplify. But here you can remove a y from both terms. Here you can't. So I'm just going to leave it like that. Same thing with the x's. I can remove a common factor of x here, but not in the numerator. So I'll leave it as it is. Okay, that's it for this one.